momentum. ठीक है, यहाँ थोड़ा different, it's really different, so you got to listen here very very quickly, carefully. The concepts are completely different when you come to photons. Very different, completely different. So please listen here. I'll write it here so that you can understand more. What is energy? If I start running, I have kinetic energy, isn't it? And then I use the expression E is equal to half mv square. So let me so in my world or our world, let's say our world, what is energy? Energy is half mv square. What is momentum? Momentum is mass times velocity. Does everybody understand these two terms? Everybody, please say yes or no. Yes, take it. Now, these things, let me tell you one thing, and this is not out of the syllabus. I'm not deviating right now. I'm coming into the syllabus as of now. These things are what is qualified under Newtonian physics. We live in a Newtonian world. So we live in a Newtonian world where we see things like traveling with tiny little velocities. Tiny velocity is also speed of a jet plane is a tiny velocity when you compare with the speed of light. It's really crawling there, right? So Newtonian physics, these things work right, but these are wrong. These are not right. These are wrong. But these are approximations. Energy is not half mv square. Momentum is not mass times velocity. But these are very, very, very good approximations. Now, if I say my mass is 50 kg, but you say, no, sir, I measured you and your mass was this much, I mean, that doesn't even make sense to anybody here because first of all, how do I measure all that, right? So the difference in actual value and the real value is so tiny that I'm fine with this approximation. And that is what Newtonian physics is all about. It's an approximation, but that approximation is very good in the world that we live in. Now, when you come to the things like photons and relativistic world, so photon world, let me write photon world. So photon world, energy is not half mv square. Energy is first of all h nu, h times frequency. Okay. And momentum is not this. Momentum is energy divided by the speed. And that actually is going to give you hf by f lambda. So that gives you h by lambda. Momentum of a photon is h divided by lambda. And energy is h times frequency. Everybody please look at this, and I'm really not well. I'll get a glass of water in the meantime. My bottle is empty. I'll be back. I'm really sorry. In the meantime, please see this. I'm back. Any questions, any doubts, please? Any questions? Anything that is not clear on this page? Just write doubts, no doubts, something. Clear, not clear, something. Can you hear me? No doubt. Okay. Shreya Bhatt says no. Science says fine. Perfect. Okay. So let's go further and we'll see the slides also here. Momentum of photon. Right? And all these are SI units, like photon, this Planck's constant is given in SI unit, right? So wavelength, when you plug in the wavelength here in SI units, not angstroms, not nanometers, but meters. That's when you get the momentum. Now, second law is applicable here also. Newtonian physics cannot be discarded. I mean, it has still to be used. So now think about a photon. Photon had a momentum. Photon collides here. So think about the light in my room right now. Can you see my hand? See, this is my palm. Photon is coming here with some momentum and photon goes back. Isn't there a change in momentum? Does everybody agree? Photon is coming here and going back with the same velocity. Velocity is a vector quantity, right? If there is a photon's momentum here, the photon's momentum has changed just now. Momentum has to be conserved. So whatever was the change in momentum here has to be given to this. So if the momentum is received by the palm, the rate of change of momentum here is the force. So as the light falls on my palm, I'm getting a force on that. It's more like You take some stones and start, or maybe a splash of water here. I experience the force. That is exactly what we are talking about. The concept is same, except that this force is so tiny I don't feel that. If it was water or stones here, I would have felt it. So as of now, your body is receiving all these photons, and you're getting a pressure, you're getting a force because of that. It's so tiny you don't feel it. Is that clear? Right. So if you take a tennis ball and throw on the wall feels the force. Similarly, when the light falls on the wall, there is a force because of light. ठीक है. If nobody is saying anything, let's try this question, please. Everybody try this. Everybody try this, please. Let's work on this together, please. Let's work on this together. So let's see what is the situation. I'll just draw a picture here before we even start the question and see what's happening here. So there is one photon here. Okay, it has some momentum. How much momentum? Momentum is h divided by lambda. Okay, it goes here and then it's a perfect elastic collision and it gets back reflected. So it still has the same momentum. Whatever was the momentum comes back. Thank you, Abhinaya. Yeah, so let's see that. Right? Now, how much is the change in momentum? Change in momentum is 2 times. So delta P is 2 times h by lambda. Does everybody understand this part? The change in momentum is 2 times h by lambda. That's all. By one photon. Okay. But there are 100 photons every second. So the total, but this is by one photon. Okay. So the change in momentum total is 200 times h by lambda by 100 photons. Okay. Now, what is force? Force is the rate of change of momentum, but that is every second anyway. So that is the same number. So 200 h by lambda. Pressure. Pressure is force by area. So that is 200 h by lambda divided by 2 square meters, and this is your answer. So now all you have to do is plug in the values. Do cut gaya anyway, so 100 times Planck's constant 6.626 times 10 to the power minus 34 divided by lambda, which is 5000, 5000 times 10 to the power minus 10. Okay, so this is your answer. All you have to do is divide it by. So whoever gave the answer, have you understood this? And also other students. Everybody, please say this. Okay, now there's nothing much to divide now. It's 5 and then 6.6. So you divide 6, 1.3 and whatever that is. Any confusion, please ask me. Anything that is not clear here, please ask me. Understood? ठीक है, Abhinaya got it. Does everybody understand? Maybe a few students made the mistake of not saying double of that because momentum is something coming back, the change in momentum is double of that. You're going with 5 kg meter per second, coming back with 5 kg meter per second. That is actually change in moment of 10 kg meter per second. Final value minus the original value. They're in opposite directions. So minus minus becomes plus. Atri says, got it. Move on. So effect of medium change, right? That's so what happens when the photons go to a different medium. Now, this is basically a property of any wave. So let's understand this. I'm not sure if you did this in detail in grade 11. So let's say when you have a wave, any wave, sound wave, light wave, water wave, there are three things that you study. One is the speed, then you study the frequency, Well, let me write frequency first because logically that comes first. So frequency. Then you have speed, and then you have wavelength. ठीक है, तीन चीजें हैं any wave की when you study that. Now frequency, please remember, it is decided by source. You need a source, right? You need a source to produce a wave, and then you need a medium to propagate that wave. So this is decided by source. Let's say I'm speaking, my vocal cords are actually vibrating. I decide how much is the frequency of the sound that is being produced. Nobody else can do it for me. If there is a string, I move it up and down. I decide if I do it 10 times in a second, or 100 times in a second, or one time in a second. I am the source. I decide the frequency. Nobody else can decide the frequency. Please remember that part. Source decides the frequency of a wave, any wave. Now, speed is decided by medium. Speed is decided by a medium, right? So let's say I start speaking. I already decided my source of the frequency, but the sound has to travel in air here. So air will decide how much is the speed depending on the density, depending on the temperature, right? Now maybe the sound is traveling in wood here, or iron there, right? Iron, metal here. So iron is going to decide the speed. So speed is decided by the medium, and poor wavelength adjusts according to velocity. This is how you actually remember this. So, now let's say I've already spoken a few words, right? So my sound is traveling in air, and then they started traveling in this frequency will not be changing because I already decided. So let's say there is a wave here, it's traveling in something here. There is frequency, speed, and wavelength. Okay. Now comes another medium. Let's say there's another medium here. So what will happen here is the wavelength might change. So frequency remains frequency, never changes. Let's say velocity increases here, so the wavelength also increases. Or velocity goes down, wavelength also goes down because velocity is f times lambda. F is not changing. If velocity becomes double, wavelength becomes double. Velocity becomes 1/10, wavelength becomes 1/10. Anybody who did not understand this? And this is typical of any wave. It's not particular about light or sound, any wave. Now, frequency is not changing doesn't mean you perceive it all the same because in Doppler's effect, it looks like a different frequency, but that's a different, completely different kind of scenario.